Slides. Good morning. So we're going to talk about IoT for a bit. One of my pet peeves is my things I like corny science fiction movies from the 90s. Does anyone remember the movie Stargate? Excellent. Good choice. I personally think that Starship Troopers is the greatest movie ever made, but in Stargate, when Colonel Nils, one of the protagonists, gets introduced, this is the first question he gets asked, like, why are you here? And his answer is, I am here in case you succeed. So it's something we hopefully wish for all of you, that as you build your projects, that you're going to be successful. I've been involved in building a number of IoT platforms, so I just wanted to share a few lessons learned, tidbits here and there. Feel free to reach out to us afterwards. But to get started, let's talk about IoT and your typical IoT presentation, which typically looks something like this. Which is fine, but you're thinking, I still can read some things, so with my Red Bull, we're going to talk about something like this. So this is like your typical level. There needs to be tons of icons and drawings and arrows between the icons, otherwise it wouldn't be a real IoT presentation. Sound familiar? Yes. So for today, we're going to do it a little bit different. So we're not going to talk about the basics on like what gets connected. I just want to share a few lessons learned. And for me, one of the most difficult things has always been data persistence in IoT platforms. Because, at least in the area I am involved in, there's a lot of data. A typical production line, I work with automotive customers. If you look at a press, for example, where the metal gets stamped, it generates about 1 terabyte of data per day. And roughly, if you look at data points, it's about 100 billion data points per day. So, of course, an unlikely candidate for storing that data would be a relational database. So, what we're going to use for IoT, I think that's another of the givens. All the cool boys and girls are using NoSQL platforms. Fine, let's dive a little deeper into that thought. And for that, I actually wanted to use a project some colleagues of mine have been working on about a delivery platform. Even though I work at Amazon, this is not Amazon, the customer. But it's a platform a customer of us built to, of course, order things, deliver them. But where the IoT part comes in is actually to give real-time updates on how long it's going to take for a package, for example, to get delivered, down to the 5-minute interval. So if you think about it from a data point of view, probably looks something like this. You have your customers. Customer, of course, his name, etc. Data. Customers place orders. Orders contain items that need to be picked up and shipped from a vendor. And then you have the driver that's going to pick up that item, pick up that order, deliver it to the customer. And of course, the driver sits in a truck, and that truck has a GPS device in it that sends updates to our cloud-based IoT platform. So far, so good. If you go down one level deeper, what's important when you're building data platforms in NoSQL databases, you need to know upfront what your access patterns are. If you're doing the traditional relational data modeling, what everyone's used to and has learned in university, like bring everything to the third normal form, super normalized, awesome. That doesn't work in NoSQL databases, because what you need to make sure is you organize your data in the right pattern to be able to support the access patterns that your application will use afterwards. To that example, so this is the relational approach to building our data structure that will support a use case. In a NoSQL database, it will look something like this. So I've taken, and bear with me, we'll go through this. There's not going to be a test on this at the end, so you don't have to take notes. But what we've done here is we've collapsed let's count 6 different tables that we had in our relational database into one single table. It's nice. It saves us money. NoSQL databases, if you use managed ones, like Mongo with the Atlas database, our DynamoDB, they can be, or they typically are, an order of magnitude cheaper for very specific use cases. So in our example, we've taken our data, and to support our first access pattern, we want to get the customer data. So my unique identifier is the email address. So in that case, if I want to query my single table to support the access pattern of I need my customer details, the name, the address, simple. I use the email address as my primary key, and as my sort key, I'm using just the string customer. So great. I have one data access pattern solved. I could do this in a single database, but or in a single table, but that would be boring. So let's see how we can cram in all these other access patterns that you see on the slide before. So the next pattern would be I want to get the orders my customer placed in a certain time frame. So yesterday's orders. Same thing. I'm going to use the customer identifier, the email address, as the primary key. And in this case, I'm putting in a time range as my sort key. So basically saying, give me all the orders where the secondary key, which is a timestamp, is in the last day. Problem solved. I get all the orders that this customer placed in the last day, or last week, or whatever. As long as my primary key and sort key are reasonably efficient, this is going to scale indefinitely. All right, next one. And this is actually super hard to see for me also. So I want to get vendor information. I need to know, okay, the driver at some point needs to pick up the package from the vendor. And in that case, simple. I'm just going to use the vendor ID that I have in my system as my primary key. The fun thing here is I'm actually overloading my primary key. I have email address as the primary key in one case. I have the vendor ID in another case. And if you go to the next pattern, it's because I want to know something about the driver. For example, where he currently is, or just his name and internal information. Again, I'm using the email address as a unique identifier, and my sort key is now driver. Which also means I can actually, if a driver is also a customer, where normally I would need to go in and put that data in a separate table, not here. I can put in actually his email address twice, and you will have his sort key in one case of customer, in the other case just a string driver. And we've solved that problem. We can now, from our single table, get the driver information also. And moving forward, I want to know where the driver currently is. So in that case, again, I'm going to stick with using the primary key of the driver, the email address, and as my secondary key, I can then query for GPS, for example, like what's its current location, where is he going to be in 5 minutes, where is he going to be in 10 minutes. And again, another data access pattern solved, and I'm still using just a single table. Are we having fun yet? Yay. Now, interestingly, there's a few things missing. For example, I want to get all the details of an order. This is where I'm reaching the limits of just using a simple table. So I've put in some additional secondary indexes that help me access the data in a different way. So we have some secondary indexes with different primary keys. It's still one table, it's just sorted differently. And they're going to look different for a customer and a driver. And of course, finally at the bottom, I also put in the details of an order. And in there, I'm using some additional secondary indexes where I'm just using the order ID as the primary key, which allows me, if I switch over to the view of my secondary indexes, I can now, for example, use the order number as my primary key. And as my secondary key, I can just get the range of the customer who placed it as a secondary index, and also the items that are in that order. So if I just query for the order ID, in this case, I'm getting everything I need to fulfill that order. I get all the items, and I get the address where it needs to be delivered. And this is, again, one of the drivers that I push my customers towards. If you're building NoSQL data structures in here, make sure you can query multiple things in one query. So in this case, if you think about the traditional relational way, I would need to go in and create my orders table, and then go to my items table, and then go to the customer details table here. Just one lookup, order ID, and I get everything in one result. It can go on and on in here to look at things at different angles. If I need to see which drivers are currently in that region, if I want to deliver something, I query by geographic coordinates. And I can go on and on in here. The idea is spend some time designing your data patterns, and you will be able to build a super scalable backend with the data that you have. The nice thing, again, about NoSQL databases is if I keep my data structure simple, that I have simple primary and sort keys, it will scale indefinitely. We have, like in Amazon, as an example, customers who are running DynamoDB with north of 2 million transactions per second. So that only works if you spend some time up front thinking, how am I going to access my data? Which is a fundamental difference, of course, from a relational database. But, as always, there's a catch. Can you switch back to the speaker notes for me? Good. Because that approach we just looked at is fairly technology-driven. If I think about it, okay, I'm going to use a NoSQL database to build what is being asked of me. The problem is I need to think up front how I'm going to access my data, and if suddenly a new requirement comes up, a new data access pattern comes up, I'm going to have trouble adapting to that. Retrofitting another data access pattern to an existing table can get pretty messy and difficult, especially in IoT platforms, at least from my experience, because you typically don't know what your customers are going to use them for when you start building them. As our CTO used to say, the platform you start building today is not going to be the platform that you're going to be running in 2 years from now. So keep that in mind. And as an example of how we can change that, how can we persist our data in a way that still gives us flexibility, but scales to a level where your typical IoT platform reaches to. A relational database is probably not the answer. We've looked at the NoSQL approach, where it's great if you know your data access patterns. So this actually goes back to some experiences had in the early 2000s. I'm old, where it's actually a similar situation like you guys have. Like, developers are in high demand. It's a good thing for everyone in this room, probably. Back then, it was similar. If you walk down the street with an HTML book in your hand, you would get hired by a startup. So back then, if you studied computer science and left university, you had a job. If you didn't have a job, you didn't want one. And I didn't want one, so I did something different. But what came out of a few projects we did back then is one of the most powerful data storage systems is a plain old text file. Probably not CSV, but Parquet turns out to be one of the most fundamentally and widely used data storage pattern or format that I see my customers using. And systems like S3 or a simple storage service where you can just dump tons of data in there, make that actually a reality, because you don't have to deal with file systems or any of that clunky stuff, because again, you can just put as much data as you want in there. So the approach we're taking with the current platforms we're building at my customer is actually to take the incoming data, completely denormalize it, where the computer science people are like, ooh, I don't want that. So enrich the data we're collecting with as much metadata as you can, and just save it as Parquet files in S3. So I've solved that problem of I've had all my data persisted in a very cost-efficient way, and then I can use tools like our own tooling, like Glue and Athena, with or Hive or Presto, with a schema-on-read approach. So I don't have to think about upfront, how do I want my data structures to look like? I just save everything denormalized, put as much additional information in there, and then apply the schema as I'm reading the data. Makes everyone's life easier, because again, you don't know what you're going to be running in 2 years from now. Okay, so we actually did something back then in early 2000 when we actually built a project for a connected house. Interesting, it was a new thing back then. And like proposing back then this notion of, no, we're not going to use a database. We're not going to use Oracle or MySQL to store the data that gets collected in that building, but rather store them as text files. That was a bit weird because the plan we had laid out or we got for implementing it, wonderful waterfall thing, 6 months project runtime, and it outlaid, okay, you're going to use a database to store the data. We actually did something super crazy back then. We actually talked to the customer. Today, we would say, like, we used an agile approach, but that wasn't invented back then, so we didn't know we could do that. So, fairly new thing. And actually, one of the outcomes was to store the data first on the file system, and that back in those days, we had to still build our own data abstraction layer on top of it, but it actually solved the problem that, same as now, a relational database at that time just didn't scale to support our use cases. So keep that in mind. Don't start with the technology first. Yes, it's cool to run Kubernetes. It's cool to work with whatever fancy technology we have. The problem is we as IT people and developers, we're kind of prone to taking stuff like that for granted. And the problem is always with stuff you take for granted is that you take it for granted. You do things in a certain way because that's how you think it needs to be done. Little examples. Anyone here over the age of 40? How many of you are wearing wristwatches? Pretty much all of you. Is anyone here under the age of 25? How many of you are wearing wristwatches? 2. There you go. For the people over 40, you're wearing a wristwatch because you take it for granted. You think, I've always done it this way, so I'm wearing a wristwatch. You don't need to. You have a phone on you, and people, my daughter, like none of her peers wear wristwatches. It's boring. It's a single function device. And I'm like, no, it's cool. It shows the day too. It has 2 functions. So again, coming back, there's some thinking behind that, is question everything. Of course, it's cool to use certain technologies, but don't use technology for technology's sake, which also brings me to another pattern that we see consistently. If you build your typical IoT platform, you will have lots of loosely coupled systems, where you take data from one system, maybe from the ingest, and move it back into your data processing pipeline. And of course, common tools used for that, things like Kafka or message queues or Kinesis service, they work well until they don't work well. Meaning, if you go back to the traditional approach of building something for the largest scale it would ever have to support, yes, you can do that. It's just something that tends to be expensive, and you have lots of hardware idling around. So again, just a tidbit on the side is use managed services that all cloud providers have available, even if you're running stuff on premise. As an example, if you use something like Kafka or Kinesis for streaming data with a, let's say, upper limit of how much processing and events it can handle per second, use something like SQS, or just a super simple message queue. If your primary data streaming platform cannot handle the peak, just divert it to another message queue. Keep it super simple, just persist it there. Tools like SQS or Google PubSub or whatever you want to use, they can take ridiculous amounts of data. They're not the primary tools for a scenario like this, but they can be useful if you use them at the right places. And of course, this wouldn't be a track in the cloud, or a talk in the cloud track, if we wouldn't talk about serverless. It's a mixed bag sometimes, because people tend to project these weird expectations of what serverless really is. For us, it's not just, okay, I have functions as a service, but if we look at how I would go in and migrate a fairly traditional data streaming architecture where data comes in to something like Kinesis or Kafka, gets picked up by a container workload running in Kubernetes or ECS, gets massaged and put into, let's say, a relational database and Dynamo in parallel. You have lots of components that are always running, that are always costing money. So what one of our customers, Siemens, Kathleen DeVolk, who is one of their chief architects, gave a talk on that at our last reInvent conference, just moving those components into serverless elements like Lambda, like storing data in S3 and using something like Athena or Presto to query it. In that case, for their specific scenario, you can result in a lot of cost savings, not just from a licensing point of view, but you don't need people operating this. I used to work in data centers. If I can avoid running servers, I will do it. So serverless or anything that it gets managed for me by someone else, even if they pay for it, this is my thing. I like using those. And then finally, this is probably less of a technology thing, but more about something how we work in our projects is to not do what I did initially. I get the customer very specific data access patterns. I'm going to start building my platform and my databases on that. One thing we always stress to our customers as you build something is work backwards. Start working from what's the expected outcomes. We write our press release and our manuals before we start building a product. It sounds a bit backwards, but for us, in my personal experience, it's the right way to do things. Because if you think about it, you remember Martin Luther King for his I Have a Dream speech. You don't remember him from his I Have a Plan speech, where he outlined how to get there to the point where little white boys and girls can hold hands with little black boys and girls. So have that big vision in place. Our fearless leader rephrased it a little bit, just saying be stubborn on the vision, know what you're trying to achieve, but don't get bogged down into decisions that you make early on what technology you're going to use, what the cool tool of the day is to build your platform, but rather use what makes sense for you at that time. All right, and with that, I'd like to keep it short. Thank you very much. If you're interested in helping shape the future of the automotive industry in Europe, feel free to reach out to me. And my colleague, Sebastian, who's also somewhere in the back, if you want somebody with an Austrian accent. Thank you for your time. This was fun. And yeah, any questions you might have, we can take them now.
Thank you. Thank you, Nils, for the talk. We do have a couple of questions. It seems like we have a lot of time to answer them. So if you still have some questions, feel free to post them through the event app or through slido.com. All right, so the first questions with most upvotes we have. Which NoSQL technology would you recommend for the mentioned data size of less than 1 terabyte a day?
Well, the consulting answer is it depends. If you ask me, hopefully it became clear, using something like S3 as your primary data storage, and then moving it into something like DynamoDB, which is, of course, our preferred NoSQL database, or something like Cassandra if you want to run something yourself. That would be the basis. But depending on your use case, it's mainly driven by how fast you need to access the data. If you need to build something like real-time dashboards, as an example, storing it in Cassandra or Dynamo would be preferred. If you're using it primarily for analytics, by all means, store it as text files or Parquet files in something like S3 and use Presto or Athena to query it.
All right, thank you. So the next question is, what are the main considerations to take into account when choosing NoSQL and not usual relational databases?
Okay. Know what you're trying to achieve. I think I also touched on that earlier. If you have a fairly good understanding of your data access patterns, NoSQL databases can be pretty awesome. They can be pretty cheap. They can scale almost indefinitely. But don't use it because it's cool. There's a brilliant example of, I forgot the team, where they decided or described their journey with starting out with MongoDB because it's cool and they were building a social network, and how that totally didn't work out for them. So every so often, I actually do work with customers making the migration back. If you have not high data velocity, if your data sizes aren't ridiculously large, a relational database is still your friend. I would say the vast majority of new applications are still being built with relational databases. So even though it's cool and looks good on the resume, don't start with NoSQL just because of that.
Right, I see that we still have some questions incoming. So the next question is, what about use cases I don't want the system to represent, like anti-cases?
I'm not sure I understand the question.
Me neither, but if you want to shout out and elaborate for that.
Share your feelings with the group.
Or they can reach you after the talk personally. So thank you. Sorry for not answering the question. All right. In which cases would you recommend using EFS in contrast to S3?
If you need a file system, very simple. If you need a shared file system between servers, EFS is the way to go. Do yourself a favor. Do not use something like S3FS, like a file system overlay over an object store, be it S3 or something else. They just don't work and scale well. So as an example, like one of my customers, they have a car configurator. I work with the Volkswagen Group, so lots of car configurators. And in that case, they need to read lots of small files to build the correct configuration that gets presented to the customer as they're building their Porsche or whatever. So something like that, if you look at the performance characteristics of something like S3, where it's great if you have few large files that you can download at ridiculous performance, S3 is great. If, like in this case, it's very frequent access to lots of small files, a traditional file system like EFS is still the way to go. Okay.
We have another question raising traction. It was new just seconds before, and now it has 6 upvotes. So how to combine 2 use cases, fast access to recent data for dashboards and historical for analysis?
That's a good point. You've seen one of an example of that earlier. I like to build something like a router component into my data processing pipelines, where at some point you feed all the data that's coming in into either a Lambda function or something running in a container on a virtual machine, where you have a configurable way to send data to different consumers. So a common pattern there seems to be you have this router component, data comes in, historical data and cold data gets routed to S3, maybe build some aggregates around it. Live data gets routed to a NoSQL database or a relational database to make it easily queryable and fast to query. And then maybe somewhere in between you have, again, another route that sends the data to Elasticsearch, so you can do some faceted searching on the data, even if your NoSQL data model is too simplistic to address every use case that you might want to build. So keep your options open, like a central configurable component that allows you to, without having to rebuild the architecture, send data to a point or point B. It's super cool. If you want an example of that, if on GitHub there's something called the Lambda fanout. It's one of a example of that some of my colleagues built, where you just have a configurable central data processing thing that you can very flexible reroute data streams to different sinks. Okay.
All right, thank you. I think we have time for 1 or 2 questions. So the most upvoted at the moment is, what would you do if you can't afford to lose data? I think nobody can. But the opinion is that transactional safety doesn't exist in many NoSQL stores. What's your take on that?
My take on that is I disagree to some extent. You can build transactional applications in NoSQL databases. If you go on YouTube, there's a brilliant talk by one of my colleagues called Advanced Data Access Patterns for DynamoDB. And in that case, or in that talk, he goes into some super mind-blowing approaches on how you can do transactional integrity in NoSQL databases. Is that something I would start with if I'm familiar with relational databases? Probably not. So your mileage may vary. Don't re-architect your application just because you can. Yes, you can build transactional databases in NoSQL. Do you want to? Maybe, but know why you're doing it.
All right, so we have time for last question. Do you see Kubernetes as an anti-pattern for serverless functions, which you just mentioned?
That's a lot to unpack there. I used to work at Google, so I have a lot of opinion about Kubernetes and where to use it or not. My main problem with Kubernetes on one side is it's driven by infrastructure people, not by developers. So it solves an infrastructure problem. So in that case, if you have a good team that can run something like, I don't know, Knative on top of Kubernetes, so you have, let's say, a function as a service thing, or you're deploying containers, be my guest. Certainly, it's a great platform. In most scenarios I've seen, it's being used without really good reason for using it. It's cool, but at least in my customer base, none of the large-scale systems run on Kubernetes yet. Because, again, you need to manage it. Even if it's a managed service, they will work great until you run into some of the quirks of Kubernetes. But besides that, if you have a good team that knows how to run it, go all in. If you're working completely in the cloud and don't have any requirements for running stuff on premise, I would take a long, hard look if Kubernetes in the traditional way is the right tool for a lot of jobs.
Thank you very much for answering all the questions. Well, not all of them, but I'm sure you get to answer most of them in person. Feel free to reach out to Nils. He'll be answering the questions in person. Thank you for sharing the knowledge. Thank you very much. Give a round of applause for Nils.
Thank you.